Okay, so we set out to create some sort of an opposite to the idea of squaring numbers. And we created this radical sign, the idea of taking the principal square root. What would happen if we took radical x and then squared it? Are these in some sense opposites of each other? Well, let's think about that. You see, if a happens to be radical x, then a times a equals x. So what do I know? Well, I know that a times a is equal to x, and I know that the radical x, we're calling that a. So when I square radical x, I get a squared, which is a times a, which is exactly x. So I get this rule. There's one exception, though. What would happen if x is negative? Well, I couldn't take the root because I couldn't find any number so that if I squared it, I would get x if x was negative, because we're working in the real numbers. So this is only going to be true if x is greater than or equal to 0. Otherwise, this wouldn't be defined because we couldn't take radical x if x was less than 0. Notice that this doesn't actually even have anything to do with the principal square root or the other square root, right? Either way, we'd be okay. This is an issue of us being unable to take the root either square root because there are no roots if x was negative. So we have a rule for what happens if you square a radical. The two operations sort of undo each other and you get the original number, so long as you can take the radical of the number to begin with.